Question 3, another design of square footing, but with unknown dimensions. We're given the embedment depth of the footing of 2 meters and a vertical load P of 1000 kilonewtons. And the challenging part in this design is that the footing is supported by 2 layers of soils, with a sand layer overlying a stiff clay. In this 2-layered soil deposit design, we start with the check of the overlying soil. We still start with the equation 10.1 to find out the QU sand as a function of FB. B is the width of the square footing using equation 10.1. And then we check the underlying soil of the clay. Similarly, equation 10.1, but here the challenging part is to find the contact area between the square footing and the top of the stiff clay. There is a load transfer principle we usually assume for this kind of problem. We assume the contact pressure transfers from the bottom of the footing to the top of the stiff clay by 2-to-1 ratio, like this. Then the contact area between the footing and the stiff clay is B plus 0.5 meters plus 0.5 meters. Then we can use a concept of imaginary footing of B plus 1 meters by B plus 1 meters. And the embedment depth is D plus 1 meter. And then B and D are the original dimension and embedment depth of the footing. So we can write Q clay as a function of B, F2B. Then we can proceed to part A to determine B using work stress design method and factor safety equals 3. Use this equation Q allowable equals Q net U over factor of safety plus Q over burden to check Q sand, QU sand, and a QU clay, which are a function of B, F1B for QU sand, and F2B for QU clay. Then you can solve for B for sand check and B for clay check. After that, you can select the bigger between these two values for your work stress design. Part B, to determine the width of footing using LRFD design, and 5 factor for the geotechnical resistance to be 0.5 for shallow foundations. And I use this equation QU factored by phi equals 1.5 times the live load plus 1.25 plus the dead load. Then you use this equation to check QU sand and QU clay separately. To generate 2B values for sand and a B for clay. Then you select the bigger value between these two for your LRFD design. And part C, with the reversed soils for the 2 layers. You just use the same strategy as used for part A and part B to solve for the width for the design.